Sharing my screen. All right, can you see my screen? Cool, thank you very much. All right, thank you very much for everybody who is here today. I'm really happy to have you here on this webinar. And also really happy also to talk about the topic of security chaos engineering, how you can start running experiments today. Um, Niels already did a very good job. He introduced me already, but just to mention that, yeah, I've already spent over 11 years, doing cybersecurity stuff. Most of that I actually did cloud-related topics. I also, before Mitigant, I had done some research at the Hasselplattner Institute as part of my doctoral thesis, and also worked at different startups. I'm also in the AWS community builder um, 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 community, one of the members there, basically. Okay, so what are we going to be talking about today? The agenda is quite, it's not so much. We will look at a high level what security chaos engineering is. Then we will discuss some of the misconceptions that I've heard from people, and I'm happy to hear if there are more that I might not have been able to hear. I'll be happy to hear those as questions afterwards. And after that, we will look at how we can start running, these experiments, security chaos engineering experiments in our own companies, or even in our own labs, how we can practice it. And then there's the topic of the security chaos engineering feedback loop. It is a very interesting topic. It explains part of the reasons why you should practice these experiments. And then I will do a very short introduction about the platform that we have built here at Mitigant that helps people to really get into this really fast. So what is security chaos engineering? Yeah, and this definition is actually provided by Aaron Reinhardt. He happens to be one of the people that started talking about this application of chaos engineering to cybersecurity. He also has written a book about it, and he defines it as the identification of security control failures through proactive experimentation to build confidence in the system's ability to defend against malicious conditions in production. Um, a couple of parts that I think are more important or should be taken note of. I highlighted it, which is to talk about how you identify security control failures, and this is through doing proactive experimentation. And in the end, you want to build confidence. You want to have confidence in yourself, in your skills, in your architecture, in your system. Confidence that you can actually go through malicious activities. Confidence that you can identify, attacks, cyber attacks, or you can be able to survive them in a much better way. So some motivations for adopting SCE, which is security chaos engineering. I might be mixing it up. SCE, security chaos engineering. Forgive me if I mix it up. We all know that today, some years ago, someone said that software is eating the world. Today, software already ate the entire world, and we got our infrastructure becoming more complex. And our infrastructure is also ephemeral. They are not static. This makes it very difficult for you to even understand the security problems that you might have and to actually tackle them. And also, we have to test our security systems. We have to test it continuously because of these two factors. If you leave gaps between the last time you tested and the next time, if the gaps are too wide, you basically expose windows of opportunity, and attackers actually look for this kind of gaps so that they can exploit them. We also observe that we have a lot of security tools today, and these tools are basically working in different abstraction layers. And these abstraction layers are based on, the way our cloud native infrastructure is organized. So you have code, you have infrastructure, you have containers, you have Docker images. And in the end, these systems are not they're not cooperating, they're not working together. And this brings a problem where they are not able to share information in a way that is easy for security people, like people, security people like incident response, to be able to fit together all these pieces of information that they can easily understand the problems there. And as we will see later, this fourth item, feedback loops are really important. If you are in charge of a system, or if you want to make important security decisions, you need to make those decisions based on something. And we find out that a lot of times people are making these decisions based on their own gut feeling or based on some information they got. Oftentimes, this information isn't really correct. It's not based on evidence, or it's already stale. So you need feedback that is accurate, that is based on facts, so you can make correct decisions. The last point is a very interesting one. It's all about cyber resilience, and today we realize that it's becoming secure is good, but in becoming resilient is even better, because security gives you the barest minimum. Being resilient actually allows you to survive attacks, and as we know, there is no 100% security today. You can get attacked. It's just like it's a function of time before you actually get attacked, and the goal is to remain online, to keep your systems online even you're attacked, so that it doesn't disrupt your businesses, your customers don't know that you're being attacked, you don't lose money. So cyber resilience is becoming more and more important. And in the end, security chaos engineering gives the ability to be able to satisfy these requirements here. Now, personally, I have been able to capture like 3 kinds of misconceptions about security chaos engineering, and I will be talking about them. And the first one is, people always come, when I speak with people, they say, well, do we have to practice SCE in a production environment? And also the other one is, people say, oh, we have to launch attacks that are complicated or complex, and attacks that are rigorous, that kind of take the entire environment away. And there's also, which is normal, like people are not very clear about the differences between ACE and other security, practices that people have been using before. So we're going to be discussing about these 3, and hopefully we can try to clarify. So the first one is, where do we conduct SE? So I actually I thought it's kind of nice to kind of classify these misconceptions as where, how, and why. For me, it kind of makes sense, where, how, and why. So that's why I'm starting with where. So the cool thing is, especially for most of us who are engineers or DevOps, either software engineers or DevOps engineers, or DevSecOps engineers, or other kinds of technical positions, we realize that we all start most of our learning journeys from our local environments. This is kind of the way most people grow, and you start learning something new from your laptop or from your PC. That's where you hone your skills initially, and definitely you progress to deploy one day to maybe in your company, you deploy to the dev environment, and then gradually you move to production. So SE is basically a security engineering practice, and it's nothing. There's actually nothing special there. It's just another way to achieve a goal. So it means that you can actually start from your local environment, and we will see a very basic example in the later slides. And at the end of the day, you want to be in production, because everything you do, in the end, you want to either serve customers, you want to offer it as a public service, and it's production that provides these values. And for SE also, you want your infrastructure to be secure, you want it to be cyber resilient, and usually it's production that will benefit the most. So wherever you start, you can start from your local environment, as I've discussed, but you want to progressively move and one day be in production. There's also the case where some companies have been able to kind of have an environment they might even call it not dev, not staging, maybe they call it the sandbox or they call it QA testing, doesn't matter. But I have this environment where they try to build it to be as good as production. Maybe it already works fine for you that any lesson you gain, in such environments can be applied to production. If that works for you, I think maybe it's already good enough. But in my own experience, I've seen that it's not very easy to have an environment that is as good as production, that you can actually be confident that whatever lessons you see in that environment are representative of what is in production. So how to conduct SCE? Again, for how to conduct SCE, also it's like I think you can start from very simple, very simple examples, like the one we see here, which we will go through later. Here we are just trying to see what happens if an S3 bucket is public, and it's very straightforward. S3 buckets, they are always public. You just want to see what happens, and the goal here is to see to prove whether maybe you have gotten some kind of monitoring systems that you deployed, and you expect that these monitoring systems will pick up that event that the bucket was made public, and they will notify you in some way. And that's just a very simple one, and you can actually think about many other kinds of similar experiments and just run them. Now, obviously, there are cybersecurity is decades old, and there are many methods or ways people have been securing their systems. I often get asked about the difference between SCE and fuzzing or penetration testing, and these are two different kinds of security activities. Maybe some people in the audience already have used it or are familiar with it. I have just actually 5 properties here. I really hope this is clear enough. It's a table where I've tried to compare these different practices with SCE. And the first one is, as I mentioned before, the abstraction layers, especially since most of us are, using cloud native infrastructure today. There's this concept of 4 C's of cloud native security, which compose of the cloud infrastructure layer, the container layer, the cluster layer, and the code. Okay, this is a mistake here. So the first one should be the code, which is the software itself. So you can actually practice SCE across these 4. You can basically write your experiments, maybe using scripts or whatever, and you can prove different properties that are important to you. When it comes to fuzzing is very popular for product security engineers, or even actually white hat hackers. They use it basically at the code layer to kind of test for security problems. Penetration testing also, actually you can do it across all these layers also. The next property is the depth of security testing, which is like how deep can you test? And usually when we start talking about the depth of testing, we are looking at things like advanced persistent threats, those kind of very deep attacks. SE, you can actually go as deep as you want. Fuzzing limited to the code, so you are just looking at the code layer, which is 1 out of 4 layers. And for penetration testing, in my own experience also, it's kind of most companies don't allow, most of the time they hire pen testers, they don't allow them to go very deep. I think the depth of the security testing is a little bit similar to the complexity. And here also for SC, you can do as you can actually bundle these attacks to the level that you think works for you. Fuzzing again is just at the code layer, and also pen test also. Automation is a very big one also here. It's a big differentiator, because in the cloud, you want everything to be automated. And when we look at SCE and we look at the history, especially from chaos engineering itself, which was started by, kind of made popular by Netflix about 10 years ago, it was all about automation. You want to make it automated. You want to take the human from the loop as much as you can. This is not the same thing for practices like fuzzing or even penetration testing. Penetration testing, a couple of people have started to automate it, but I think it's still like at a very basic, it's still very basic as at now. Now the persona type here is about more like the kinds of people, like the experience or the positions that can practice SCE. So for SCE, it cuts across different kinds of engineering practices, whether you're a cloud security engineer or in a SOC team or incident response team. It all depends on what you want to test, because because of the different abstraction layers. Fuzzing, I think it's majorly product security engineers and DevSecOps, and penetration testing also is kind of limited to those people who are responsible for pen testing. Yeah, so I think I already talked about this, and this is just a diagram to kind of drive home this idea of the forces of cloud native security. So you got the code here, which could be Lambda functions, could be your normal code written in any programming language. Container, as we know, could be Docker containers or other kind of Linux containers you might be using. Kubernetes cluster, it could be either be any of the distributions that the cloud service providers have, like EKS or the one from Azure or Google Cloud. And the cloud layer, obviously, we are talking about all cloud service providers. So basically, you can practice SCE across these 4 abstraction layers as you wish. Okay, so we'll actually go through this one pretty fast, and this is also another kind of similarity. So we got red, blue, purple teaming, and these are different kinds of ways where people are testing their environments. I will not go deeply into how different they are, but just to say here that we've already talked about automation. SE is really more about automation most of the time. These other guys, red, blue, and purple teaming, are manually conducted by the experts, and they conduct it kind of periodically, because again, it's kind of domain knowledge, and they cannot do it continuously, whereas SE is, we can do it continuously. And what I found out after speaking with a lot of people, which we always do, we always speak with customers, we always speak with people who try to ask questions around SE. Most of these other activities are currently done in on-premises data centers. Obviously, the body of knowledge is gradually kind of moving over to the cloud, whereas for SE, everything basically started from the cloud with Netflix when they started their chaos engineering practices. So it's been kind of motivated by cloud native systems. Then we have this issue of kind of the manpower. SE basically, like I said before, you can start writing the scripts, based on the knowledge you have of the infrastructure, and you understand what the problems are. You can write the scripts, you can test it, you can do it again. Whereas for this other red, blue, purple teaming, most of the time, except for big corporates that have the financial resources to hire in-house teams, whereas most of the time they outsource this to consultants who have the capabilities. Yep, and we have this other two, this last two items here. One is for learning opportunities, where, and this is kind of a little bit technical, but when you try to understand, in the beginning there was red teaming, and after some time people brought in blue teaming, and later they realized that there was this kind of disharmony between both teams, and the idea of purple teaming came in to kind of try to solve and bring these two dimensions or sets of people together. So there's always that that discussion around whether they are actually productive enough, and it's not really learning, so to say. SE is purely based on learning. You want to learn, you want to observe, you want to learn new things about your environment. And of course, the issue of time and resources is, I think it's kind of straightforward. So when you when you automate processes, you save time, you save resources. So now it's very important to understand that SAE is purely about experimentation. It's based on scientific processes. And what I mean by that is, we know in most scientific disciplines, you have an input, and you have a target system, and you expect an output. In most cases, you don't know what the output is, and that's why it's an experiment. And you want to the idea of carrying out that experiment is for you to discover what the output might be. You might have a hypothesis, you might have a gut feeling, you might know something that happened before, and maybe it's not maybe it's not going to be the same output at the end of your experiment. So so here, for SCE, you have a hypothesis, and then we'll see an example later. And it's very simple. What's your gut feeling? What's your belief? And you inject it, and in the end, if you prove it, then maybe you're happy, and you build confidence, and you know that under these specific conditions, your environment will behave in the way that it just behaved, and that gives you the confidence that, well, you're doing something correct. If you disprove it, then that means you know that, well, there are issues around your system that you need to basically fix. So how do we go about starting SE experiments? You have to adopt the right mindset and the intent. And what I mean by adopting the right mindset and intent is, you need to understand, or you need to adopt the mindset of, I wouldn't say researcher, but that openness and willingness to learn. And you need to adopt the mindset that you are looking at your system from the alternative perspective. So you are basically assuming that your system is already breached, and you want to actually prove that it's not breached. Of course, you have to define your goals, your objectives, what do you want to achieve. You don't just want to attack your system to that it becomes unhealthy. You want to really achieve achieve specific goals, and you have to start small with something like a hello world SE. You might something very basic, basically. So here is an example, the one we already saw before in the picture, and this example is kind of straightforward. Basically, your hypothesis here could be like, you will get a notification from guard duty whenever an S3 bucket becomes publicly accessible. This is a very big problem, happens even in 2023. We're still seeing S3 buckets that are becoming public. And in order for this bucket to be public, there are a lot of ways, and bear with me that here every example is purely on Amazon Web Services, but it could also be that you are doing it against Azure or Google Cloud Platform, or maybe you have some on-premises systems that you want to do it. I think it can work anywhere. It all depends on your knowledge and what you want to achieve. But in this example, we are using the AWS CLI, and what you see here is basically you're executing this command to make the bucket completely public, and there are like a couple of levels of what you want to do. But here, basically, you want it to be public. You also want to allow the ACLs, the access control list. And there are like 3 or 4 configurations that makes the bucket completely public. We'll not go into details here, but after you do that, the output here is probably, you expect that you will get a notification from guard duty. So guard duty is basically a threat detection system that is native to AWS. And by the way, you have to switch it on before this happens. So if you don't switch it on, if it is not enabled, then you wouldn't get any notification. And if and you also have to, if you remember the diagram we saw before, the notifications in this case are kind of tied or configured to be sent to Slack. So this is not going to be happening by default. So if it's not configured this way, it means you have to go to the Guardity console and basically, kind of search for the notification using some search parameters. But in this case here, we assume that it's already configured, Guardity is switched on, and it's configured that it sends the event notification to Slack. And when I tried this, what I observed is it takes something like from 10 to 20 minutes or more before you even get the notification. So if it was something, maybe if in real life, maybe this bucket had very important information. For example, it had some things around maybe social security numbers or financial information. Then there is going to be a window of like 20 minutes from when the attack started until when you got the notification. Might be that it's already enough time for the attackers to completely, download all the objects in the bucket. Might be that the attacker already had time to proceed to other targets. Might be that it's okay for you. It depends on your environment. But let's say that maybe it's not okay for you. A possible countermeasure here to improve might be that you enable the S3 bucket event notification, which is a feature of the buckets, which is kind of like, let me say, a hidden feature. But what happens here is immediately there is any API call against this bucket, you're sending that the notification it's configured to be sent to a Lambda function, and from the Lambda function you're sending it to Slack. And actually this is going to happen almost in real time, maybe not real time, but almost. It's definitely going to be better than the approach which we had before. So in this case, at the end of the day, you have successfully been able to observe that what you've done previously wasn't as efficient as you wanted it to be, and you have implemented something that is much better and something that is much more secure. All right, so let's quickly have a look at the feedback loop I talked about, and it has basically 5 steps: plan, execute, monitor, analyze, acquire insights. So the planning stage is kind of it's basically what you do at the beginning of most things you want to plan. And during this process of planning, some things you have to do is more like talk about the aim of your experiment, the hypothesis, the scope of the next experiment if this is not the first one. And if it is if it is not the first one, probably you are kind of creating backlogs. So for example, in the previous example, you saw that we created a better way using S3 bucket event notification. So this could have been already something you create in the backlog, probably assigned it to an engineer who's going to implement it, or you maybe already planned a certain sprint where you will implement this countermeasure. Then the other thing here is you have to factor in the experiment's outcome for subsequent security activities. So this is very interesting because, in some companies, they usually have things like threat modeling, they have tabletop exercises, they have different kinds of activities. So it could be that you want to discuss things, you want to use this as one of the items on the agenda. So you can discuss it with your colleagues and you can improve the awareness, you can spread the knowledge around. Basically, the next step here is execute, and is basically here you're basically executing, you're conducting the experiment, whatever you had planned. You're gonna be exercising your plans. the point here that I think is most important on this slide is about safety. And what I mean by safety is the first point here, communication. So you have to talk to people. You have to let people know what you're doing. You have to spread the word. You have to use whatever channels you have in your company to spread the word and make people be aware of what you're doing. This is really, really, really important. And also, the steady state is basically the idea that you should be able to um, kind of take a snapshot of what you're going to do before you begin to change it. So in the previous example, you saw that we made a bucket to become public, and the steady state of this bucket, of that bucket at that time, was probably it was a private bucket, and it was private, and it had certain configurations to make it public, to deny ACLs and things like that. So you can actually use different approaches for this. Probably you can use things like, if you are using infrastructure as code, it means that you have all the settings written in code, either Terraform or CloudFormation. And then after the experiment, you basically reapply that, and it basically goes back to how it was before. So then that is basically this next step, which is about recoverability. So you're basically at the end of the experiment, you have to, like, roll back. Monitoring is also very, very important here, because when you start your experiment, you had an aim, you had an objective, and you want to observe the flow of the experiment. How do you do that? Probably you have logs, you have tracing, you have things like maybe you have configured dashboards, maybe like Grafana. The reason for doing this is because if things go bad, or probably during the experiment, maybe you didn't foresee certain impacts, it begins to disrupt the operations, then you have to, like, stop the experiment and roll back to the steady state. So this is very, very important, and you have to put in measures, to be able to stop an experiment and roll back. So let's look at analyze. So here is also another important thing, because at the end of the experiment, you want to analyze it. You want to know whether your hypothesis was proven. You want to ask yourself a couple of questions. For example, were there some unexpected behavior that you didn't know before? Maybe there are some kind of cascading failures or cascading impacts across your system. You want to take note of all of these and kind of factor them in, or use that knowledge for something better. And as we mentioned, if the experiment failed, you will like to investigate why it failed. Maybe there was something that you forgot about, and you can actually put that in place so that the next time the experiment does not fail. Very important here is about using risk-driven methodologies. So as you know, especially those in security, security is such abstract that usually it's hard to quantify things. And when you begin to speak with either, especially when you want to speak with management, or you want to make requests around budgeting and all of that, you have to fall back to risk-driven methodologies. So, and there are a lot of these kinds of methodologies out there. Here, I just give the example of the OWASP risk rating methodology, because it factors in different kinds of different aspects are kind of important. So as you see here, it looks at the threat agents, it looked at the attack vectors, the weaknesses, the controls that were impacted, the technical impacts, also the business impacts. And when you go through this kind of analysis, you're able to really have a logical conclusion of what happened, and it makes it easier to make decisions, either yourself, or to speak with management, or to speak with whoever. So you have to figure out the one that works best for you. Now, the last step of the feedback loop is insights, to acquire insights. I think this is really, really important because when you do these experiments continuously, you learn, and you need to like keep all these learnings in a way that you can reuse it or you can share it. And there are a couple of use cases. So, for example, what we did was to kind of um, improve the what we had before using S3 event notifications and Lambda, which is this is just one example of what you can do, because with this you can use that as a knowledge to apply not only to S3 buckets but to other infrastructure that other kinds of services you're using in your infrastructure. Um, and the next one is also really interesting. Today we have a lot of people using machine learning, to do things like detection engineering. I've also had people, asking me about detection engineering, how they can leverage security chaos engineering, to test how efficient their algorithms are able to detect, how they're able to detect attacks. And usually, this is kind of challenging for cybersecurity today, because every environment is kind of special. It is contextual, and you even when vendors give you when you acquire all of these tools from vendors, they come bare, so they have to be fitted for purpose. They have to be fitted for your own environment. So if you can use security chaos engineering to kind of inject these attacks, and then it rolls out data, and you get data sets that are really, really contextual to your environment, and you can feed them into your models, and then you basically improve your detection engineering efforts, or incident response, or whatever you want to improve. Okay, so we're coming to the end. So I've said a lot of things, and what we are doing at Mitigant is basically to lower the bar for practitioners, for people who want to adopt security chaos engineering. We want to lower the bar, and we are doing a couple of things here. We are automating a lot of the processes are kind of automated, for you to be able to inject attacks, e.g., for example, ransomware attack, which actually is a combination of multiple attacks. It combines several steps, and this is a kind of a use case we have. So with a click of a button, you can already roll it out, and then you can analyze the impact. We can actually get for you evidence from the cloud, either from GuardDuty or from CloudTrail, so you can actually see exactly what happened, and then it makes it easy for you to achieve cyber resilience. Of course, at Mitigant we do other things. So we also offer compliance management. So it makes, if you are really, really, I mean, this is actually common across most industries. You want to be compliant. There are different benchmarks out there that people try to be compliant with, and then we're able to do that with our CSPM. So just on a final note here, we have talked a lot about security chaos engineering, and it is something you can start practicing by yourself. They are not like open source tools out there, so you can basically think about all these problems that you think you might have in your infrastructure. Write a bunch of scripts. They don't need to be complicated, and just inject them and see what happens. Learn from them, repeat it, and gradually you'll see that you begin to already gain a lot of knowledge from what you're doing. So thank you very much for paying attention. Thank you very much for staying to the end of this webinar. And now I will hand over to Niels for the Q&A session.
Yeah, and we will stop recording now. So